Hi there. I need you on page 355 out of your math book, and I want you to determine which one of these four does not belong. Take a second and do that right now. So, hopefully, when you were determining which one doesn't belong, you had justification for why you thought that way. Some of you might have said that A doesn't belong because it's the only one where both of those vectors point to the right. You could have said B doesn't belong because it's the only one where both vectors point in opposite directions and they're different lengths. You could have said that C doesn't belong because it's the only one where both vectors point in opposite directions and they're the same length. Or you might have said that D doesn't belong because it's the only one where both of the vectors point to the left. You probably just heard me say the word vector. Now, a vector, it's kind of like a ray, only a ray has a starting point and it goes forever in whatever direction that the arrow is pointing. Okay? Those are rays. Vectors, on the other hand, they have a starting point and they have a stopping point. And putting that dot right there signifies the stopping point, okay? Now, in these particular examples, their vectors are shown like this. They have a starting point, represented by that, and its stopping point is represented like that, okay? So these right here are both vectors because vectors show the starting, the direction, and the stopping point, okay? Now, something we're going to be doing today is we're going to be using vectors to represent equations. So, if I were to write an equation to represent this situation right here, it would look like this. We started off with 3, and then we added to it, because we're going to the right, we added 4 more, and that solution is 7. Now, this situation right here, we started off with 3, and then we added to it 1, 2, 3, 4, 5, 6, 7, 8, 9. A negative 9 because it went to the left. And our solution to that is negative 6. Now, another way to represent this exact same equation, you might have heard of the distributive property. Well, right here I have a positive times a negative 9. Well, a positive times a negative is a negative or a minus. So another way I can rewrite this exact same equation is 3 minus 9, and we'd still get negative 6. Now look at this one right here. You'll see we have something called additive inverses or opposites. So when I'm representing this with an equation, we start out with that 3. And then since we're going to the left, we're adding to that 3 a negative 3. And 3 and negative 3 are additive inverses or opposites, and their sum is 0. Another way to represent this situation is by rewriting it like this. Positive times a negative 3 is a minus 3. And 3 take away 3, that's 0. Okay, and let's look at D. You'll see that we are starting out with negative 4 because it's going to the left. And then we're going to the left even further, so we're adding to that negative 4 a negative 5. And that sum is negative 9. Another way to represent this situation right here is by using the distributive property and taking this plus times this negative 5, and a positive times a negative is a negative or a minus. So that's minus 5, and then bringing down our negative 4. So negative 4 minus 5 still gives you that sum of negative 9. All right, guys and girls, I need you on page 356 out of your math book now. And what I want you to do first is I want you to double check the number lines in your math book. Some of the math books have an error where they made a mistake when they were putting the numbers on a number line. Whenever you put numbers on a number line, you have to make sure you're jumping consistently. Okay? So you'll see that in the number line, we're jumping by intervals of 5. So double check that it shows 0, 5, 10, 15, 20, 25, 30, so on and so forth. And to the left of 0, it should say 0, negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, so on and so forth. And if it hasn't been fixed yet, go ahead and fix those on your number lines, please. So now that you've had a chance to double check or fix your number lines, I want us to go ahead and start number 1. We're going to be completing the table and drawing a number line diagram for each situation. So let's go ahead and take a closer look at that row A right there. You'll see that the starting temperature was 40 degrees. And the change that occurred was that it got 10 degrees warmer. So if I was going to represent that using a sentence, it would say if the temperature starts at 40 degrees and increases 10 degrees, what will be the final temperature? Well, 40 plus 10 is the addition equation that represents a situation, and we know that the final temperature would be therefore 50 degrees. Now we need to represent that using a number line diagram. So I'm going to look at this number line A, and we started at 40 degrees, but on your number line, you need to make sure you're starting at 0, okay? And draw your vector, and it's going to go to the right until you get to 40. Make sure your vector stops and it shows that direction, okay? So that right there represents this part. Well, it got 10 degrees warmer. So from this point right there at 40, we're going to go 10 degrees to the right and then show that it stops after increasing by 10 degrees. Therefore, our sum is 50, okay? And that's what gets written right there. So again, this equation right here is 40 plus 10 equals 50. Let's go ahead and take a look at B. Well, we're starting at 40 degrees. So draw your first vector right there to get to the 40 degrees. Make sure it stops. And you'll see that the change that occurred was it got 5 degrees colder. Well, that's going to go to the left because we're getting colder. So we'll start from right there. You'll go to the left 5 units, and that puts you at 35 degrees. So our final temperature right there is a positive 35. Now for our equation, it would look like this: 40 plus a negative 5 equals 35. Okay? You'll see that I wrote an addition equation because that's what's required in this last column right here. I want you to also know that another way to kind of represent this situation would be with this equation. Taking this positive times this negative 5 because of the distributive property, it can be represented like this: 40 minus 5, and that gives you that exact same sum of 35. Now, the only reason I wrote this equation in this column is because this column specifically wants us to have an addition equation represented right there. So that's why I have that plus sign right there. 40 plus a negative 5 is 35. Okay, C says, well, the starting temperature is 40 degrees, and the change that occurred was it got 30 degrees colder. So go ahead and represent that using vectors. Let's go ahead and use the vectors like your math book showed us on the first page. So we start at 0. We go to the right until we get to 40. Show that your vector stops and it's going to the right. And then it's getting 30 degrees colder. So from this 40, we're going to go to the left. Go to the left 5, 10, 15, 20, 25, 30. So it's going to stop us right here at the 10. And our equation that represents this situation would look like this: 40 plus negative 30, and that gives us a sum of 10. Another way to represent this exact same equation would be 40 minus 30, and that gives you the same sum of 10. So I need to fill out the information right here. My final temperature was positive 10 degrees. Our addition equation is this right here, and that gives us 10. All right, take a look at D. Your starting temperature is 40 degrees, then it got 40 degrees colder. So represent that. Start at 0, go to the right 40 degrees. And then since it got 40 degrees colder, we're going to go to the left 40 degrees. And our final temperature was 0 degrees. So our equation that involves addition for this situation right here is 40 plus a negative 40. And another way to represent what's going on here is, a positive times this negative 40 because of the distributive property gives us a minus 40. And 40 minus 40 is 0. Okay? Now I want you to take a second right now and I want you to complete E. So you'll see with E, our starting temperature was 40. It got 50 degrees colder. What is your final temperature and what is your addition equation? All right, and here's what should have been represented on your number line. And there is your addition equation as well as the final temperature represented inside your table. All right, now I'd like you on page 357, and I want you to complete this table and draw a number line diagram for each situation.